Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, in this particular session, we are going to discuss some basic concepts related to tuple relational calculus. Then we will see 3 or 4 questions related to tuple relational calculus which have been asked in the GATE exam, but that discussion will take place on the application. You can eventually join the link. That class is absolutely free. Okay, so basically it's a YouTube plus app series. So I'll discuss the concept on the YouTube and the practice questions will be discussed on the application. Okay, let's move further. This is a brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience, and the following are the achievements and areas of expertise. Okay, yeah. So guys, this monsoon, there is a very good announcement for you that BYJU'S Exam Prep team is coming up with the monsoon series. In this monsoon series, we will come up with the videos which will be helpful in boosting up your GATE rank. So please subscribe for the channel and press the bell icon to get the notification so that you can be part of this monsoon series. Let's move further. Okay, so Dheeraj Sardana sir and Abhinav Negi sir is going to conduct a workshop on 2nd of July 12 p.m. In that particular workshop, sirs are going to discuss whether 7 months are enough or not to secure AIR 100 rank in GATE. So if you guys are having any doubt that whether 6 or 7 months are sufficient or not, then this workshop is definitely for you. Kindly register for the workshop and attend the workshop. This is absolutely free. It will take place on the application. Okay, let's move ahead. So what are we going to discuss today? We are going to discuss the concept of tuple relational calculus. People who don't know predicate logic or have not tried to understand the tuple relational calculus may find it very difficult, but this thing is damn easy. There are simple rules. You just need to follow those system rules, easy rules, and you will be good to solve any question of GATE exam related to tuple relational calculus. So let's try to understand what is a tuple relational query. What type of query language is this? It is a non-procedural query language. So basically there are some syntax defined. If you write the language in the particular syntax, correct syntax, then you will be able to execute the query and you will be able to retrieve the desired result from the database table. Why do we call it tuple relational calculus? Because it is based on the evaluation on the tuple, or a tuple variable is used to produce the result in this particular case. Now, what does it uses? It uses the concept of first order predicate logic. What do I mean by first order predicate logic? It uses the basic predicate operations like and, let me say and, or, negation, etc. And it also uses the quantifiers such as for all there exist. Right? So this thing can be used with the tuple relational calculus. Therefore, to understand the tuple relational calculus, you should have a basic knowledge of first order predicate logic. Okay, so very good evening, GATE ESE CSE. Let's move ahead. That what is the basic syntax of tuple relational calculus? That's what I said. If you know the syntax, you can give the answer of any query asked in the GATE exam. So it's simple. The basic syntax of TRC is this actually represent a set. Okay, this will be a set, and what will be the result in the set? The result will be specified by this tuple variable t. So this is a set of tuple variable t such that the predicate condition pt is satisfied. So what did I say? What will be the output of the TRC? A set of tuple variables t such that condition pt is satisfied for those tuples. Right? So where t is a tuple variable and pt is a predicate formula that describes the condition that must be satisfied by the resulting tuple. So only those tuples will be in the result. Those are satisfying this predicate condition. Clear? Now, it results the set of tuples t such that pt is true for t. So if this condition is true for a tuple, then that tuple will be available in the result. Now, there are some syntaxes that if you write t belongs to R, then it means that the tuple t belongs to relation R. It denotes that the T is a tuple from relation R or belongs to relation R. That's what you need to understand. Now, a tuple or and we are talking about relational, right? So in relation there will be different attributes. So if you are interested in a particular attribute A of the relation, then T is a tuple variable, and if you write T A, then this is nothing but a value of attribute A in tuple T. So in each tuple there will be a value corresponding to that attribute. So if you write, like, come on, if you say this is a table student, and if you have a attribute SID, there will be S1, S2, S3, this is one tuple, this is another tuple, this is another tuple. So if you are saying T SID, then with respect to this first tuple, T SID will represent this S1. With respect to second tuple, T SID will represent S2. For the third tuple, T SID will represent S3. This can also be denoted as T dot SID. There is nothing wrong with that. You can also write it as T dot SID. So T bracket SID or T dot SID, both are same. There is no difference, right? So this is the way of representation. Now let's try to understand that there is a equivalence between all three types of query language. So following are equivalent. What if you are trying to say that select distinct, because by default SQL query language will not produce distinct tuples, but this projection and this is also a set, right? So set will always have distinct tuple. This is the property of set. You cannot have duplicate tuples in the set. So this is producing a set. Therefore, obviously there will not be duplicate tuples with respect to output of TRC query as well, right? So this too will produce distinct tuples, but this first one may eventually produce duplicate tuple. Therefore, to have the equivalence between three, there must be a distinct keyword in the select clause for the attributes, right? So that's okay. Let's move ahead. Following are equivalent. So what does it represent? Select distinct asterisk from employee. So it will represent, or it will eventually produce everything from the employee table, because you are saying asterisk means all the attributes from the table employee. You can simply say employee, or you can say projection without any attribute specification. So if you are not specifying any attribute in particular, then it will project all the attributes. It will project all the attributes. What's the concept of TRC? Now you will say a set of tuples T such that T is a part of employee. So all the tuples of employee table will be produced. All the tuples of employee table will be produced. So when you write it in the form of TPT, then this T is for, it is known as output tuple variable. What do we call it? Output tuple variable. Output. So it will eventually be used to produce output. Why do we use it? Used to produce output. So that's okay. Here, in this particular example, we were trying to project all the attributes of the table employee. Therefore, we did not have to specify anything. We just had to say that result the tuple T such that T belongs to employee. So T belongs to employee, or T, this is predicate. So predicate employee is satisfied by T. It's the same thing. When, if I say P is a politician, I hope you have attended the sessions on predicate. So P is a politician, if I say so. And if I say P of Ram, then what does it mean? It is Ram is a politician. This is what it means, that Ram satisfies the predicate. So this is the exact same thing. T belongs to employee, or T satisfies the predicate being an employee. That is, T is part of employee. So you can write it like this. Clear? So this is a valid representation to define that T belongs to employee, and this is also a valid representation to represent that T belongs to employee. So that's okay. When you want to project everything, from the employee table, that's a different thing. But if I tell you to project only names of the employee, in the employee table there may be various attributes. Let's see, there are EIDs, there are e-name, there are salary, there may be various attributes in this table employee. But we are interested only in the names of employee. So what will you do? Here in the relational algebra, you will simply say project E name from the table employee. You will simply say project E name from the table employee. But what will you do in the TRC? So you will say the tuple must belong to employee. So you are saying tuple T must belong to employee, but you don't want the information of the complete tuple. You only need the attribute E name from the tuple T. You only need attribute E name from tuple T. Got the idea? So you can specify this in this particular manner. Now that's one way of doing it. So there are multiple ways of doing the same thing in the tuple relational calculus. Therefore, kindly try to follow everything, and if you have any doubt, please ask me. Right? So you might feel at point that, sir, what if this happens? So you can actually ask it. Right? So that's okay. So in this case, we wanted only one particular attribute of the employee table. What if we want multiple attributes? So let's try to understand this, that this is an example. Retrieve SIDs of all the students, SIDs of all the students from the relation student, SIDs of all the students from the relation students whose marks are more than 50, whose marks are more than 50. So you will eventually say what? Sir, what do you want? You want the SIDs. So you will write, so let me write in a different way. So there are various ways of writing the same query. So you will say, let's say that T is my tuple variable, and let's assume that this tuple variable T actually belongs to the relation student. T belong to the relation student, and what other conditions which must be satisfied by this tuple? So this T must belong to the relation student, and then you will say whose marks are more than 50. So in this tuple T, if marks, I can denote it like this, right? Or I can write it like this, T dot marks, same thing. If T dot marks are greater than 50, then you are interested in this particular tuple, but you are not interested in the complete, you are not interested in the complete tuple, you are interested only in the SID present in this tuple. So you will eventually say T dot SID. So you will say we want SID of tuple T such that tuple T belongs to student, and in the tuple mark should be greater than 50. Clear? Please try to understand that. If you are not giving any response, then I would believe that okay, everything is clear to everybody, right? So anyway, so that's one way of writing this. Another, you may say that okay, T is a tuple such that T belong to a student. Is it valid? No, sir. No. Can we, I mean, if we do so, then eventually we are going to get the complete tuple. So we can do what? Let's try to understand that we can eventually instantiate it with a different tuple variable. So you may say, let's assume a tuple S belongs to a student, or there exists a tuple S belonging to a student such that what is required in that particular tuple? Such that in the tuple S, the marks must be greater than 50. Marks must be greater than 50. And so either you can, let me write it, and. What do you want from that tuple? What information do you actually want from that tuple? So you need a tuple T, but what is this tuple? We don't know this tuple. We don't know that what information is available in this tuple. In this particular case, we eventually knew that this tuple T is a part of a student and there will be various attributes, right? So T will be a tuple from relation student and all the attributes of relation student will be part of this tuple T. So we need only the SID, therefore we could initialize it with T dot SID. But in this particular case, we are saying that there is a tuple variable T, but with respect to a student, we are not using the same tuple. We are simply saying if there exists any tuple S belonging to a student such that in the tuple S marks are greater than 50, and you will write something, you will write what? T dot SID equals to, so in the tuple in which marks are greater than 50, in the same tuple S, the SID of that tuple will be included in the SID of tuple T, will be included in the SID of tuple T. So what is happening here? Here we are creating the tuple. This is nothing but the creation of attributes of tuple. This is creation. Initially we just said that there is a tuple T, but what are all the attributes present in this tuple? So we are saying this T dot SID, if you write this, then this eventually will create attributes of tuple T. Which is your output tuple variable. What is, sir? When scientists technical assistant exam. Dates are not yet announced yet, I guess. So as soon as the dates are announced, we will come up with the notification. We'll let you know that what are the exact dates, right? Okay. Can I do anything else? Can I do anything else? So sir, we could do this, or we can do this, that we can use a separate tuple variable for the output, and we can eventually select the tuples from the relation using a different tuple variable. So this tuple variable which is used as an output tuple variable is a free tuple variable. What type of tuple variable? Free tuple variable. What do I mean by free tuple variable? Free tuple variable is a tuple variable which is not preceded by the quantifiers, right? And this tuple variable which are being used to define the tuples of the inside relation, these are known as bounded tuple variable. These are known as bounded tuple variable. So now this is a situation in which we only needed the SID. If we need SID as well as name of the student, then what will happen? Let's look at this. Retrieve SIDs and names of all the students from the relation student whose marks are more than 50. Now what will you do? What will you do? Sir, we will simply say there are two ways of doing this again. So you need two different information, the SID and SNAME. Therefore, you will say that we are saying that tuple T will eventually belong to relation student. Tuple T will belong to relation student, but from that tuple T, we don't need all the information. We need only what information? We need SID and comma, we need name from that tuple T. So this is one way of creating the attributes in the output tuple. Now, this T belongs to a student, and what? T should belong to a student, and in the tuple T, the marks must be greater than 50. So it will result all the tuples in which marks are greater than 50, but from those tuples we will project only SIDs and name. What are you saying, Vikash Mishra? Which logic gate is known as agreement gate and why? Agreement logic will be, and the two things agree or not on same thing, right? Thank you. Okay. Now, the similar thing can be done in a different way as well. What I said, let's use that the tuple variable is T only. Let's say that the tuple variable is T only, but we are saying that there exists a tuple S. If there exists a tuple S belonging to relation student, such that S dot marks are greater than 50, then if this condition is true, then only we will move ahead. So we'll read from left to right. So if this condition is true, then we will move ahead and we will say what? Okay, S dot marks are greater than 50, therefore we have identified a tuple S from table student which is satisfying our condition. But what do you want from this particular tuple? We want two attributes from this tuple. What? One, we want that T dot SID should be equals to SID value in this tuple S, and we also want the name from this tuple or we also want the name available in this tuple S. So we will eventually create these two attributes in the tuple T. Got the idea? So this creation of attribute, or you can say used to project SID and name from the selected tuple. Clear? Okay. Let's move with the next example. So this is all related to student. Now let's try to come with the relations which we have discussed in the relational algebra as well as in the SQL, and try to identify something based on those relations. So there's a relation supplier which consists of SID, IDs of supplier, name of supplier, and the city which they belong to. Parts table in which there will be ID of the part, name of the part, and color of the part, and then the catalog table which consists of the information that which supplier has supplied which particular part at what cost. These are the information available. So now I am asking, find SIDs of all the suppliers who have supplied part with PID equals to 1. Now the very first thing which you need to ask yourself is that we need the SID of the supplier who have supplied the part with PID equals to 1. This information is available in a single table or multiple table. This information is available in a single table or multiple table. So sir, this information is available in a single table, that is catalog table. So you can actually say that let's assume that there is a tuple T such that that tuple belongs to catalog table. There is a tuple T that belongs to catalog table, and now you will say what? Sir, T belongs to catalog table, but what is the condition? T belongs to catalog table. Tuple C. Sorry. We need only SID. We don't want the complete tuple. Therefore, we'll say if you want only SID, then you can actually say T dot SID such that the tuple T belongs to catalog table, and there are some other conditions. What? Sir, in the tuple which is belonging to catalog table, the part ID must be equals to 1. Yes. So T dot PID must be equals to B1. So T dot PID equals to T1 is satisfied. Then you have found the tuple T. You have found the tuple T from the catalog in which PID is P1. Now from that tuple you need to project only SID. From that tuple you need to project only SID. You can also do it in a different way. What? You can say that okay, nothing, but there's a tuple T. We don't know what this tuple T is, but we'll create this tuple. But for time being, let's assume there exists a tuple C belonging to table catalog. There exists a tuple C belonging to table catalog such that in the tuple C, PID is equals to P1. In the tuple C, PID is equals to P1. So you have found the tuple C in which PID is equals to P1, but now you need to create the output tuple based on this tuple. So you'll just say, and we actually want the SID. We actually want the attribute SID in our tuple T. We actually want the attribute SID in tuple T, which will eventually be the SID which is present in this tuple C. So we'll say T dot SID equals to C dot SID. Clear? Got this concept that there are two ways. Either you can define the attributes itself along with the tuple variable, or you can use a separate tuple variable, and you can use use a different tuple variable for the relation, and then once you have selected the tuple from the relation, you can eventually create the attributes of the output tuple. You can create the tuples, you can create the attributes of the output tuple. Is this clear? Okay. Now let's try to understand a different example. Consider the following relational schema: supplier, part, catalog, C. Now this time it is asking for the SID and S name of all the suppliers who have supplied part with PID equals to P1. Now the idea is the supplier has supplied the part, it's okay, but the name of that supplier is available in the separate table supplier. The name of the supplier is available in the separate table supplier. So you will be left with no choice, but you will say, okay, let's assume that this T is my tuple variable. Let's assume T is my output tuple variable such that, and now we want T, so we'll say if there exists a tuple C belonging to catalog, if there exists a tuple C belonging to catalog such that in that tuple C PID is equals to P1, and so if this is true, you will move ahead. If this is true, you will move ahead, and along with that, if there exists a tuple S belonging to supplier, if there exists a tuple T belonging to supplier such that, what's the idea? Now you have two tuples. One is the tuple C, one is the tuple S. What do you want? The supplier in the tuple C who has supplied this part, you want the name of that particular supplier. The supplier who has supplied the part P1 with respect to catalog table, you want the name corresponding to that SID. So you will say, see, you want the supplier with SID which is equal to the SID which is present in the tuple catalog. So you will say C.SID should be equals to S.SID. If it has happened that you have eventually found a tuple S in the supplier table such that the SID is equals to SID in the tuple C, then you will say that, okay, I have found the tuple S. I have found the tuple S in the supplier table corresponding to the SID who has supplied the part P1. Now the only thing left is to produce the SIDs and name from that supplier relation. So you will say, and now creation of attributes of tuples. You will say, and T.SID in the tuple T, there should be an SID which will be same as SID of tuple S. So at this point of time, you can say SID of tuple S or you can say SID of tuple C because both of them are equal. Therefore, here you can say T.SID equals to S.SID or T.SID equals to C.SID. So that's okay. That's one thing. But we have created only SID. We also need name. So you will say we also need the attribute S name. We also need the attribute S name from. But now see, the attribute S name cannot be taken from tuple C because tuple C does not have the attribute name. So you will simply say T.SName should be equals to name SName. So that's okay. You just need to balance the brackets. Done? So that's okay. This is how you can give the information. So this time the information of part which was supplied by the supplier was present in the catalog table, but the name corresponding to that SID was present in the supplier table. Therefore, you had to use two quantifiers. Now, let's move with the next example. Let's look at this. Consider the following relational schema: supplier, part, and catalog. But this time, we are saying that we need SID and SName which will be available in the supplier of all the suppliers who have supplied some red color part. So, supplier has supplied which part, that information is available in the catalog. The part, color of that part will be available in the part table. If it is so, then only you will go and say that, okay, if this information is available, that supplier has supplied a part PX and the part of color PX is red, then you will eventually like the information about the SID which has supplied the part PX, and you will also like the name of the supplier, right? So, that's the idea. Now, what will happen, sir? You will say select a tuple T such that if there exists, so let's look at this. If there exists a tuple C belonging to catalog such that no. This. If there exists a tuple C belonging to catalog and there exists a tuple P belonging to parts, because you need to compare two things, such that the PID available in the catalog is the same as PID available in the parts. So such that C dot PID is equals to P dot PID. This is okay. If the PIDs are not same, then you don't need to go ahead. But if PIDs are same, then you also need to check the color of that PID, and the color with respect to tuple P, if it is equals to red, then what will you do? Then you will say, and there exists a tuple S belonging to supplier. Now you will say, okay, I have done with one thing. I am done with one thing, that we have seen tuples from catalog and parts such that there is a tuple in the catalog C, such that whatever ID is available in that particular tuple is same as the ID available in the tuple of part table, such that the color is red. So whatever SID is available in the tuple C, that is the SID of the supplier who has supplied red color part. But now we need the name as well. So we'll say that if there, and to produce that name, you will have to say, and there exists a supplier such that, C dot SID, that whatever SID is present in this catalog table, this should be same as S dot SID. Then you have selected the tuple in the supplier table as well, which is corresponding to that particular supplier who has supplied this red color part. So now you will be left with, and now you need to create the attributes of tuple T. So you will say T dot SID should be equals to C dot SID or S dot SID, no matter, because basically these two values are same. So T dot SID equals to S dot SID, and T dot SName should be equals to S dot SName. So this is bracket close, this is the second bracket, and done. This will give you the tuples which are with respect to that thing. Okay, now that will be all. We have seen the basic concept. Now we'll try to understand them with respect to questions. But one last thing, which is unsafe query. Sir, what is unsafe query? So we are actually trying to produce the tuple which belong to the relation. But unsafe query is something, let's say if I say T such that T does not belong to the relation. So how many tuples are there which does not belong to the given relation? How many tuples will be there which do not belong to the given relation? So there may be infinite tuples which do not belong to the relation. So you can say there may be infinite tuples which does not belong to a relation. This thing is same as saying tuple T such that not the tuple T belonging to relation. Both of them are same. So we are first saying that we are producing the tuple T such that T belongs to relation. Then we are saying we want in the result the tuples which are not part of this, or which are not satisfying this condition. So this tuple T will be produced with respect to tuples which are not satisfying this condition. So again there will be infinite tuple. So what do I mean by unsafe TRC? Or TRC query which may produce infinite tuple. A query which may produce infinite tuple is known as unsafe TRC query, right? But a Cartesian product in TRC is just like this. So this and this is the Cartesian product of catalog and parts. When you write there exists some tuples belonging to catalog and there exists some tuple belonging to parts, then you are trying to check each tuple of catalog with each tuple of part, and that's what happens with the cross product. Clear, GATE EASY CSE? What happens in the cross product? In the cross product, try to combine each tuple of catalog with each tuple of parts, and that's what happening here, that we are trying to compare each tuple C of catalog with each tuple of parts one by one such that they satisfy the certain condition. Clear? Anand, it is yet to be finalized, I guess. So at this point of time, I don't have any exact information or accurate information about that, Anand. So once we have the accurate information, we'll definitely let you know. Okay, so this is unsafe TRC. Now we will try to understand the questions which has been asked in the GATE exam. So for time being, just try to attend the session at the application in which we are going to discuss the practice questions on the tuple relational calculus. So I'll join the session in just 1 minute. You can log in the application and can attend the session. So from here, bye bye. We'll meet at application in just 1 minute.